Latent heat, also known as latent energy or heat of transformation, is energy released or absorbed by a body or a thermodynamic system during a constant temperature process. Latent heat is the energy absorbed or released by a substance during a change of physical state, like melting, freezing, boiling, or condensing, without any change in its temperature, acting as hidden energy to break or form molecular bonds. This heat is used to overcome intermolecular forces, not to increase kinetic energy, temperature. Latent heat can be understood as hidden energy, which is supplied or extracted to change the state of a substance without changing its temperature or pressure. This includes the latent heat of fusion, solid to liquid, the latent heat of vaporization, liquid to gas, and the latent heat of sublimation, solid to gas. The term latent was introduced around 1762 by Scottish chemist Joseph Black. Black used the term in the context of calorimetry, where a heat transfer caused a volume change in a body while its temperature was constant. The main formula for latent heat is Q equals M times L, where Q is the total heat energy absorbed or released, M is the mass of the substance, and L is the specific latent heat, constant for the substance. This equation calculates the energy needed for a phase change, like melting or boiling, at a constant temperature, with L being the heat per unit mass, typically in joules per kilogram. In contrast to latent heat, sensible heat is energy transferred as heat, with a resultant temperature change in a body. Heat is energy in transit due to a temperature difference, flowing from hotter to cooler objects, manifesting as atomic, molecular vibration. Faster movement means more heat. In thermodynamics, heat is defined as the form of energy crossing the boundary of a thermodynamic system by virtue of a temperature difference across the boundary. A thermodynamic system does not contain heat. Nevertheless, the term is also often used to refer to the thermal energy contained in a system as a component of its internal energy, and that is reflected in the temperature of the system. For both uses of the term, heat is a form of energy. Calorimetry is measurement of heat by its effect on the states of interacting bodies, for example, by the amount of ice melted, or by change in temperature of a body. In the International System of Units, SI, the unit of measurement for heat is the joule, J. Major types include sensible heat, changes temperature, felt, and latent heat, changes phase, for example, melting, ice, with ways to transfer it being conduction, convection, and radiation. Ways heat is transferred. 1. Conduction. Heat transfer through direct contact, touching a hot pan. 2. Convection. Heat transfer through the movement of fluids, liquids or gases, like warm air rising. 3. Radiation. Heat transfer via electromagnetic waves, requiring no medium. Sunlight, fire's glow. As a form of energy, heat has the unit joule, J, in the International System of Unit. In addition, many applied branches of engineering use other, traditional units, such as the British Thermal Unit, BTU, and the calorie. The standard unit for the rate of heating is the watt, W, defined as 1 joule per second. The symbol Q for heat was introduced by Rudolf Clausius and Macorne Rankine in 1859.